Hi class, it's me again. Now we're on to question number 13 in lesson 5.5. And this one again, we're still practicing with all these identities and formulas. And this one asks us to find the exact values of sine 2u, whoops, got the wrong thing here. Exact values of sine 2u, there we go, cos 2u, and tan 2u. Okay, so we can see our double angle formulas. I actually copied them here for you, but you know they're on your formula sheet, so you have those available. And basically, we just got to understand what this problem is really looking at. So they give us this interval that u is between 0 and pi over 2. That kind of tells us that it's in the first quadrant. Okay, so we can easily just draw this thing right away. So here's the first quadrant, and I know the hypotenuse is 5 and the opposite is 3. So it's probably something like this. So there's the angle u. I know I've got opposite is 3, hypotenuse is 5. There's the hypotenuse, and there's the opposite up here. Okay? So it's really nice. Once we have the picture like that, we can do anything. The one thing we probably are going to need is this side. So let's just quickly calculate what that is. We can use Pythagorean theorems. We have 5 squared equals 3 squared plus, what should I call that? I'll just call it x squared. Okay. And so we have 25 equals 9 plus x squared, and we have 16 equals x squared, and x equals plus or minus square root of 16. But with the minus, I mean, that wouldn't really make sense. We know we're in the first quadrant. We know we're in quadrant 1, so we only need the positive, so x equals 4. Okay. By the way, it wouldn't hurt you to memorize this triangle, 3, 4, 5. It's a triangle that does come up a lot. But anyways, there we have it. We have all the information we're going to need. So let's go on and solve the problem now. So first thing is sine 2u. Sine 2u, well, look at this. We have sine 2u right here. It's given in our equation. So we just write it down as 2 sine u cos u. I'm just replacing theta with u. And now we can easily tell what sine 2u is because we know what sine u is. Sine u, in fact, they give it to us. It's just 3 over 5. That comes directly from the question. And then cos u, we know is adjacent over hypotenuse. So that's adjacent over hypotenuse. So that's 4 over 5. And so there's our answer. Let's see, what would that be? 2 times 3 is 6 times 4 is 24 over 25. Check. One thing done. Carry on from there. Cos 2u equals cos squared u minus sine squared u. That comes from this formula right here. Okay. And so again, no problem. Cos u, we already said we know what that is. It's 4 over 5. And we square that. And sine u, we know, is 3 over 5. So we square that as well. Well, let's save a little bit of space here. We have 16 over 25 minus 9 over 25. Whoops. Over 25. And so does that equal 16 minus 9? That would be 7 over 25. Okay. Cool. Almost done. Last one is the tangent. So we can use this formula. No problemo. Tangent 2u equals 2 tangent u over 1 minus tangent squared u. Okay, so 2 tangent u is opposite over adjacent. Okay, so we have 2 times 3 over 4. Yep, that's over 1 minus, again, tangent u, but this time it's squared. Okay, so the 2 and the 4 cancel. Let's see, 2, this makes this a 2. So we have 3 over 2 in the numerator, and we have 1 minus 9 over 16. Okay, move back over here. I'll keep that 3 over 2 in the numerator. Denominator, we now have 16 over 16 minus 9 over 16, adding fractions. So that's 3 over 2 over 16 minus 9, did that already. That's 7 over 16. And so that equals, wow, a lot of math here. 3 over 2 multiplied by the reciprocal, which is 16 over 7. And finally, we can do this. That becomes a 1. That becomes an 8. 3 by 8 is 24 over 7. Wow. Lots of work. All right. So, I think that's it. Yeah, enjoy.